everyone. In this video today I'm going to be demonstrating Coulomb's law of electricity of charges. Here I have two separate charge bodies, charge Q1 and charge Q2. Charge Q1 has a charge of -4 microcoulomb and charge Q2 has a charge of +8 microcoulombs. So it means that the charges are of different magnitude as well as of different signs. So they are opposite charges, with Q2 larger in magnitude than Q1. Now let's see what will happen to the forces. You can see the forces acting on both charges. Force Q1 is on the left, or sorry, the charge Q1 is on the left and charge Q2 is on the right, and the distance between them I have made in such a way that it is 10 cm. So we want to look at how the distance between them affects the magnitude of their charges, and as well as the magnitude and the nature of the charges also affect them. Here, let's start with this. So if you see the distance about, you can notice that the force on Q1 by Q2 is just 28.760 Newton, and the charge on Q2 by Q1 is also the same, with the same magnitude. And let's check their directions. Now as I pull closer, take a look at their directions. You can see that charge Q1 is pulled to the right, and the force acting on it by Q2 is the same as the force acting on Q2 by Q1, but their directions are in the opposite direction. So Q1 acts in the right and the magnitude increases, you can see, until they become closer. So you see that when the charges are very close to each other, the magnitude of the force increases, which is the Coulomb's inverse square law. So you notice that an increase in the distance between the forces reduces the forces, and a decrease in the distance between them increases the forces. Now I have increased the force or the charge on Q1 to -8 coulomb. So it means that both charges are of the same magnitude but different nature. So let's look at what happens. You can simply notice that the forces are increased now. So it means that when the charges are increased, the magnitude of the charges are increased, the force on the charges will definitely increase also. So you see, but the directions it also remains in the same direction. See, the forces increase when I'm moving them closer, and they decrease when I move them further away. Now I have made them to be of equal signs, that's positive, but different magnitude. Now let's look at their direction. You can see that the forces are repelling each other. As I move them closer, they repel. Can you see the direction? The force on charge Q2 points to the right, meaning that it is being repelled, and the charge on force Q1 points to the left, meaning that it is also being repelled. The magnitude of the forces are exactly the same. You can see that when they are closer, the magnitude increases again. Now they are of the same sign, positive signs, 4 coulombs and microcoulombs and 8 microcoulombs. Now I have changed both charges to negative charges. Now let's see what happens. Now when they come closer, the magnitude of the force increases. You can also see that the direction of the forces are different. Now the nature of the force, or the magnitude of the forces, is very small compared to when the charges are very large. See that the charges are very small. Here I have decided to increase the magnitude of the charges. Now when I pull them apart, you see that the forces reduces. Then when I pull them closer to each other, they tend to repel each other because the direction are in opposite direction. See the forces increases considerably because the charges on the magnitude of the charges on the particles are very large, -9 coulombs, microcoulombs, and -8 microcoulombs. All right, that's all for today. Thank you for watching this video.